Okay, morning everyone. Let's get started. So first of all, welcome to the new semester and welcome to this CS 5350, 6350, the Introduction to Machine Learning course. And I'm very excited to have you all in this classroom. So before we start, I would like to briefly introduce myself. So my name is Shandian Zhe. The last name sounds weird because this is the not typical English name. It's a Chinese name. So you can, if you feel like hard to pronounce that, you can call me Shandian Z, Shandian or Professor Z, Dr. Z, or Z, whatever you like. Right? I totally understand. So weird, yeah, sounds weird. So I'm an assistant professor at School of Computing. Right now, it's named as Cahors School of Computing at University of Utah. So my research area is machine learning, of course, and I focus on one specific branch of machine learning because machine learning is really large direction. So I'm doing probabilistic machine learning. So I'm very excited in this area, especially, this rapid progress in machine learning. So right now, people are all talking about AI, right? Artificial intelligence. But to me, it's just a declaration of machine learning because the horsepower of AI is actually machine learning. If you wipe out machine learning from AI, then AI won't be like today, right? So the many incredible applications you have seen, you have heard from artificial intelligence actually was made by machine learning. And honestly, to me, when I was a PhD student, I even cannot imagine nowadays those problems can be addressed by AI, right? Like computer vision, like autonomous driving, like Go players, right? So we're going to talk about those amazing progress and applications in recent years, right? And for me, here I just listed a set of research topics I'm working on. I'm working on Bayesian nonparametrics, Bayesian deep learning, probabilistic graphic models, large-scale learning system, high-order structured data analysis, embedding learning, physics-informed machine learning, and I'm very passionate. I'm always passionate to apply machine learning to address a variety of problems, right? Like how do we make better recommendation? How do we advertise, make the online advertising better and easier? How can we reduce the cost for scientific computing? How can we analyze brain image data, cancer data, to help diagnose or even help with the treatment or arrange operation rooms? And we wrote some proposal to help smartly arrange operations in University of Utah Hospital. Excuse me. Oh, is my voice too low? Oh, okay, yeah. Oh, I forgot to mention that. If you feel like my voice volume is too low, just let me know. I'll try this, but my experience is that most cases this thing doesn't work. Okay. Hello? Oh, nice. Okay. I guess I'm gonna hold this. Okay. So I will be working in this area. Okay. Maybe it's too loud. Okay. So if there's no option to reduce the volume. Okay. I'll try to hold here. Oh. Sorry. Hello? Okay, thank you. So I'll be working for this area for more than 2 years, right? I'm always excited by, it is kind of like beautiful combination of science and engineering. So it's mathematically elegant, but also from practical perspective, it is effective. So that's basically my background. Oh, okay. Let me try to. Hello? 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 Hello?
Probably on this panel. Yeah,
On this panel?
yeah, that's your microphone, right?
Oh, thank you. Hello? Oh, it doesn't. Hello?
Except that now it's still open.
Yeah, it doesn't. It's working. Oh. Hello? 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 Try this one. Hello? Hello? Oh, this one is better. Okay. Thank you. Sorry for apologies for any inconvenience. So again, if you are interested in doing any research related to machine learning, and if you'd like to talk to me, feel free to come to me, send emails to me, or come to stop by my office or in office hour. Right? So today, here's our outline we would like to discuss. So first, I would like to give a general definition of machine learning and talk about those applications, amazing applications, progress of machine learning, right? And then we'll talk about the course content. I will specify the course requirements and policy, homework assignments, projects, and etc. I feel it's extremely important to explain what do we expect in this, what do we expect in this course, right? So this is not an easy course. You might have a saying, I heard from others, like this course might be challenging. In some sense, yes, in some sense, not. I just want to clarify what is the possible challenges you might face, so that to give you enough time to make the choice. Right? And then we're gonna go through some basic knowledge before we talk about the first machine learning algorithm. Is called decision tree, right? So by the way, if you have any question you would like to discuss with me, or you want to want me to clarify during the whole lecture, I mean throughout the semester, just feel free to put up your hands or just ask. Right? I'm very happy to interact with you guys during the class. Right? Actually, I encourage you to do so. I don't like everyone is silent in my class. Right? That feels like I'm just doing a solo show in my lecture. That's not good. Okay, so first question, I want everyone to think about what is learning, and more specifically, what is machine learning. Right? Anyone would like to share your thought or understanding about learning?
We made a mistake or do something wrong, learning to not make that mistake again.
Okay, yeah, that's a very good angle. So basically means that, okay, you might try and you found some mistake, you can correct the mistake, and you will never make the mistake again. make the same mistake again, right? Okay, any other comment? Okay, yeah, you're reaching out to something very essential. We're going to talk about the essential ability, but also connects to what you said, is the generalizability. Right? It's not simply memorize the examples you have learned. You must be able to generalize to some new examples, new cases you have never seen. Another thought? Apply new what? New skills. Oh yeah, right. But I would like to say, okay, this kind of skill applied to some new environment, that might be more accurate. Yeah. Okay, another thought. Oh, okay. Yeah, that's another good angle. So actually, this line of thought actually is the key idea for one line of research is called lifelong learning or something like that. You keep updating yourself, keep make you better and better. Another thought? Understand better? Yes, exactly right. So you see that in many learning procedure, including the machine learning algorithm, they're trying to extract patterns from the so-called training data. So we expect that that kind of patterns can be applied to new problems. Right? Okay, another thought? Yeah, that's great. And thanks for providing so much useful and insightful thoughts. So to further get some sense about what is learning procedure, right? Let us play a game, right? Of course, it's kind of mind game. So suppose you travel back to 1994, right? That was like the baby stage of machine learning, right? A conference is called Computational Learning Theory, International Conference on Computational Learning Theory, also known as COLT. It's kind of like top venue in machine learning theory. This year, the attendees were asked to play a game, right, which we call the badge game. So the attendees, each attendee received one badge. Of course, the badge has its name, right? So if you got a chance to join some academic conference, you usually have a badge and put your name, your title, so that you can say hi, you can get to know each other, right? But at that year, the badge also has some label, right? So you got plus sign, meaning that you have a positive label, you have a minus sign, meaning that you have negative label, but that doesn't mean like they classify as bad guys or good guys. It's just some kind of label generated by some unknown function, right? And across all the attendees, only one person knew the underlying function that generated the labels, right? And he told the other attendees that, okay, your label is only dependent on your name. Okay. So the task, one task, was allocated to these attendees that, okay, everyone please go and look at as many examples as you want in the conference and try to figure out the unknown function. This is called badge game. Right? So suppose you were one of these attendees and you have talked to 6 persons, right? And you collect their names, their labels listed here, right? So now, that means we have collected a bunch of data, right? We know what is the truth of the target label. And can you guess the rules or the underlying function which generated those labels? So everyone, please take a look at those table with only 6 examples. Try your best to guess what is the underlying rule. Just give me a random guess. What? Decreasing alphabets? Repeating alphabets. The first letter. Yeah, that sounds interesting. Any other thought?
Stop counting letters, even our odd numbers of letters.
Yeah, I heard the same rule in previous classes. Yeah, that's one good match. Any other thought? I heard someone. Okay. Yeah. Okay. Yeah. Another additional thought?
That's the letter. I heard someone say the first letter.
Yeah.
The last letter. The last one. The last letter.
The last letter of the first name or last name? The full name is EMHD. So your meaning, can you explain again?
So for example, so the last letter of the full name,
Mhm.
the counting point is N.
The counting point is N.
Yeah, before N, it will be minus, and after N, it will be plus.
Oh, yeah, that's a novel function.
Really?
Yeah, that's something I never heard from my previous classes. Yeah,
Thank you.
yeah. Actually, have created a decision tree to make prediction. Yeah, that's very nice. Any other thought? Okay, yeah. Thanks for providing your best guess. But I would like to summarize our playing procedure a moment ago as a typical learning procedure. Right? So why? Because it consists of 2 steps. Right? First step, we collect the data. Right? Although the data sounds little, right? Looks a feel like we only have 6 examples. It's not like modern machine learning examples. We use millions or even hundreds of millions of examples. Right? And once we collect the data, we try to figure out some patterns or rules or underlying functions, whatever you call, right, to match the input and output, right? You want to fit the training data with the rules that you come out in your mind, right? So that's a typical learning procedure. And we missed some additional step, which we call test, right? We should collect another 10 more attendees' names and their labels, so we can test that if your function, which well matches the training data, right? We'd like to say if this function also predict well in the test data. Right? So playing a batch game is a typical learning procedure, right? But now it's a human being who play the game, right? So if we replace human being by program, by robots, by machines, this is called machine learning, right? So hope this simple game can give you a little bit more concrete sense about how this learning procedure works. Right? Any question? Any thought? What? What is the pattern? Oh, I can release the answer. So actually, it's a well-known problem. Later, after that conference, those organizers have released the real function which generates those labels according to our names. Unfortunately, it's different from all the rules you guys have come up. Yeah, exactly. Actually, when we after this semester go through, we will learn some basic computational learning theory. You will see that how the sample size will affect the generalization ability of your learned model. Right, that can partly answer your question. But here we just want you guys to have some kind of experience. What is learning? You're doing this every day, right? And but perhaps rarely people will think about, okay, how can we formalize these learning steps and procedure? Right? It's actually a very, very important problem in both psychology and artificial intelligence, because people so far haven't decoded what is the true learning procedure. Right? There are a lot of like arguments between this. Right? Okay, so now I want to introduce like the recent amazing progresses made by machine learning. Right? That makes artificial intelligence research again. Right? Artificial intelligence was proposed. This name was proposed like maybe 80 years ago, or even earlier. Right? It has like several depressions. Right? And at the beginning, the pioneers of artificial intelligence researchers was very optimistic. Right? They feel like, okay, they will spend like 3 months to build up an intelligent machine, and things turn out to be much harder. Right? And after like 10 years like prosperity, and then people found out, okay, they won't be able to really build up intelligence. Right? And then the research study went to the depression, right? And then with some kind of progress, like especially in 1980s, the popularity of neural networks and expert system, artificial intelligence becomes hot again, and people found out, okay, they still have a severe bottleneck. They're restricted to a very specific domain, and it's very hard to generalize the larger domain, and then they become depression again, right? So now we're going through the third resurgence of artificial intelligence. And this time, I believe it's not only the bubbles, right? There is some kind of real things, right? And which surprise people and which kind of like benefit our daily lives. That's something I want to show to you guys, right? So the first one is called AlphaGo, right? So how many of you have heard of AlphaGo? Okay, how many of you know Go rules or is able to play Go game? Oh, you know that? Oh, nice. And I have to say that I'm a total loser because I was born in China, and Go was invented by Asian Chinese people, but I know nothing about Go rules. I haven't know how to play Go, right? Go game. Yeah, but I can tell you that when Deep Blue was invented, how many of you have heard of Deep Blue? Oh, nice. Yeah, I thought it was just an antique, like many years ago, right? But at that time, I was in my middle school. That was also kind of surprise, the breakthrough of artificial intelligence. And IBM built up a superpower machine that can play chess game and wins the champion of international champion. He's a Russian. He's Russian. His name is Kasparov, and he's a well-known like genius in that domain, right? But he was defeated by IBM machines, right? But at that time, like I remember some journalist asked the inventor of Deep Blue, said, "Okay, how do you feel like human-made machines is gonna win human beings in Go game?" They said, "I cannot imagine that." Right? It's reasonable because it's so hard, right? If you compare the state space of Go game and the normal chess game, you'll see that the state space of Go game is like many orders of magnitude more than the chess game, right? So if you got some chance to read literature, you see that the idea of Deep Blue is just to build up super fast machines which can fast search over the possible space, and they have some smart pruning strategies, right, to avoid useless search. But for Go game, never think about that, because no matter how smart heuristic rook or heuristic search you can invent, you can still not avoid the explosion of search space. So you must think about other methods or other algorithms, right? So for long term, computer scientists or even AI researchers have never been able to vision that sometimes the human the machine learning Go players would be able to beat human players even at very simple level, right? And things got changed until I guess it's 2015 or 2016, right? And Google developed this so-called AlphaGo, right? They used deep neural networks and called Monte Carlo tree search. Monte Carlo tree search is a classical algorithm, right? And it's kind of like random search. It is useful, but not as powerful as people think. So I know many machine Go player researchers tried that, but never got good progress. However, when they combine this Monte Carlo tree search algorithm with the deep neural networks in the reinforcement learning framework, and things got changed. Because with neural networks, they kind of like mysteriously capture those information from the layout of those black and white pieces. They kind of sense put a tiny piece on different positions can lead to what kind of change of your chance to win, right? And they can train this by repeatedly playing the game by themselves, and eventually they beat the legend players of, I think, from South Korea, right? And later they played, they won the new world champion, that's Chinese player, and that player cried in front of the machine, right? So that's really amazing, right? Because only after 20 years, less than 20 years, like people have made another breakthrough in this Go game. Right? Maybe this is the most complicated human game, right? And I guess another well-known breakthrough recently is called generative models. So nowadays, it's so easy for us to create funny images, right? You just input some text, right, here, and then some automatic program, we're going to generate those nice images which reflect what you're talking about, right? And I haven't got a chance to put some like machine composite music, right? When I was a PhD student, when I joined some Google campus or Google campaign, they showed us like what kind of music composed by machine learning algorithm, right? That time it was composed by adversarial neural networks, and sounds not bad. Okay. So this is another type of applications, right? It's not only funny, right? Those game players or not game players, the game developers, they often want to make some funny pictures about the game characters or cartoon characters, and they want to generate this, right? If you can automatically generate, they can save a lot of cost because they do not need to hire a professional painter to do all this. And actually, in addition to those fancy applications, right, machine learning has already penetrated everywhere in our daily lives. Maybe you have never be aware of them, right? So like the most commonly used application is actually the online advertising and product recommend, right? If you log into Amazon or eBay, whatever online website, they always try to recommend you some combination of products, right? They try to steal more money from your wallet. It's really annoying, right? And but this is how they earn the money, right? And you see that the Google, Facebook, and a lot of like online internet companies, their major revenue comes from selling this or selling or pushing advertisement to you. Right? And all those are on the line driven by machine learning algorithm, right? They hire, so there's some kind of sarcasm, like a few years ago, like they said, okay, Facebook and Google like hire the smartest brain in this world and trying to advocate or sell the advertisement to you. Right? What kind of waste of a life? But this is how the general revenues, right? Revenues, right? And also, like voice recognition, like Siri, I guess everyone is familiar with that, and autonomous control, right? So if you have some program control, you can even let the helicopter fly in this way, right? The propeller is in the bottom. It's very hard. If you ask the human players to do this, they won't do that. It's too hard, right? But machine learning can do this. Right? Actually, this video was released about 10 years ago, developed by a Stanford team, and they won their best application paper in SML, a top venue in machine learning conference. They show that their machine learning controller can do this, right? And autonomous driving, right? So how many of you have heard of this? Oh, nice, right? So you know, I think the most well-known autonomous driving system is Autopilot, right? From Tesla, right? So honestly, I don't want to be the guinea pig to try this one, right? But nowadays, even I want to try this, I have to pay $50,000, and price is increasing, right? It sounds crazy to me, right? But this on the other side shows that how machine learning is trying to, or not trying to, has already impacted our lives. Right? And it's funny that if you look at several, if you make a little bit survey on this type of techniques, you know that like Tesla Autopilot might be the only entity that uses full machine learning techniques. That means just using networks and cameras in front of car, your Tesla, or the back of Tesla to make decision, to make recognition, to control the car. So although it's not perfect, we definitely agree that it's not perfect, but it works like pretty well in practice, right? So this actually has already shown that, okay, the potential, the power of machine learning, right? Hopefully in the future, they kind of make it like more reliable and reliable enough that human beings can really, you know, don't release our hand from the wheels. Okay, so in summary, machine learning is everywhere, like starting from like emails, spam email detection to finding all people in the photo, or you know, civilians monitoring, all those kind of stuff. Machine learning has already been in with our daily lives. Right? That's why I think nowadays, like people when talk about artificial intelligence, talk about machine learning, it's no longer a science fiction, right? It has already with us, right? The problem, of course, there will be a lot of other problems, like what kind of ethnic stuff, right? When you use machine learning or artificial intelligence to recommend things or to make decisions, sometimes legal decisions, right? There are some kind of research or even like using machine learning to make trials or to determine whether I'm gonna have you allow you to be in a to detain you or to release you, right? So there comes another problem. So the fairness or the fairness of AI, the trustworthy of AI. So a lot of problems, like not only in scientific or engineering perspective, but also in society perspective, in psychology perspective. So you see that AI is kind of like co-living with our human society. Right? There are a lot of problems, also means a lot of opportunities. Right? Okay, but after bragging so much potential and bright future about machine learning, right? Because this is my domain, right? I want everyone to get excited by this area. What is learning? What is the definition of learning? So at least we should give some kind of formal definition of machine learning, right, before we talk about the details. So the definition of machine learning actually also has some kind of evolution path. It's not fixed at the very beginning. Right? So in 1950s, this pioneer researcher, Professor Arthur Samuel, he defined machine learning as a field of study that gives computers the ability to learn without being explicit programmed. Okay? So it's not like very straightforward, right? But just like, okay, if I want to recognize if this image contains a person, contains a cat or not, I wouldn't tell the specific rule to this program. Right? I don't need to tell the program that, okay, look at the face, look at the pixel 1, 2, 3, what does it look like? And I don't need to specify particular rules or particular set of rules or functions. Right? I want my program can automatically extract or construct such rules by going through a set of training pictures. So only when your program has such kind of ability, you can say, okay, you're doing machine learning. Right? You're not just encoding your own heuristics into binary series. Right? Okay, so in 1983, Professor Herbert Simon gives a more formal definition, right? So he said that learning denotes changes in the system. Such changes in the system are adaptive in the sense that they enable the system to do the task more effectively next time, right? That actually matches some of you who give the definition, right? I want your program can get better in doing some particular type of tasks, right? That is called learning, right? Learning means improvement. And in 1999, Professor Tom Michel gives an even formal definition, right? Which we're going to use that as our definition. A computer program is set to learn from experience E, right, with respect to some class of tasks T, and also have some performance measure P. If the performance at tasks in T measured by P improves with experience E. Okay? It's kind of lengthy, but basically it tells out, okay, when we consider some learning problem, right, we got to have 3 factors, right? First, experience E, right? So later we'll say, okay, this experience E, I can represent training data. Right? We have some training data to learn, right? And with respect to some class of tasks T, meaning that what is the range, what is the type of task, right? And also we need some kind of measurement to measure how your program performs in doing tasks in T, right? So we need to come out with some performance measure P, right? Then with these 3 factors, then we can say, okay, if you feed your computer program with some data experience E, and you measure how your program does for task in T with this performance measure P, if it improves, then we can say, okay, your program is learning something. Right? Any questions so far? Everyone's good at this? Feel good about this? Okay, great. So what do all those definitions reflect? Right? It reflects that the nature or essence of learning actually is to gain some ability to generalize. Right? What does it mean for generalize? Generalize means that I'm not going to just repeat the examples I'm saying I learned, right? I must have some ability to deal with new examples which I've never seen, right? For example, suppose I want to train my machine learning algorithm to recognize dogs, right? I collect a bunch of dog pictures, right? Puppies, then I should be able to capture what is the essence of concept dogs, right? So now if I present a new picture about dog, I should still be able to say this is a dog, not a cat, right? Although it wears a fancy glass. Right? Any questions so far? Right. Okay.
Some program learn from directly design picture and new one.
It's just one example. Yeah, because in practice, yes, exactly, right. And I wouldn't say like 9 is not totally impossible. It depends on what kind of algorithm you're using. Like some kind of like we call it like one-shot learning. They pre-train some model, big model, a giant data set, but not specifically for recognition of dogs. Then maybe you just use 9 pictures, can let that model start to recognize dogs. It is possible. I'm not saying it's totally impossible, but I do not have a piece of code, a program in my hand to show this to you. But I just want to explain that, okay, what is the essence of learning, right? Learning is not just to memorize past things. You must gain some kind of ability to generalize. Okay. Any other question? That's good. Very good question. Okay. So now, motivation, right? Why do we study machine learning? They give you, I mean, most superficially, they give you a bright future because so many applications, so many business are built upon machine learning. You might earn a lot of money, right? That's the most superficial stuff, and I'm very frank. I do not want to pretend to be, but in addition to that, right, from the scientific perspective, why should we study machine learning, right? We're always curious to, or eager to build computer program the system with new capabilities, right? It's kind of like curiosity. We want to understand nature of human learning. Right? Want to address some kind of key issue in psychology, right? And ultimate goal is that, okay, want to develop robots that can learn as human beings, right? So that we can get free from like so many heavy tasks, right? And you can let robots to finish a lot of like difficult tasks for you. Of course, there might be some rebellions of the robots, right? We have seen this in many movies, right? Hoping that they won't come, right? But you just build up kind robots, not bad robots, right? But who knows, right? So one give the system the ability to perform tasks in a situation which has never been encountered before. This actually talk about the generalizability, right? And with the accumulation of the data, right? So now there is a big data era, right? And it's never possible for human beings to look over those data. Right? Everyone knows that there's huge value inside this data. Right? How can we do that? Right? How can we extract value of all of this data accumulated? Machine learning is one way, because it was designed, or its goal is to extract rules, knowledge, functions, whatever useful stuff to human beings out of data automatically and efficiently. And right now, like, people are starting to make inroads into end user facing applications already, right? There are so many applications we have talked about, right? Showing the power of or convenience of machine learning. Okay, so far I'll give a very broad and rough introduction of machine learning. I specifically brag about why machine learning is so promising, so good, right? Hopefully, under this big goal, under this promising goal. Everyone feels exciting to study this course. So now let us talk about what is this course about. So as an entry level of machine learning course, right? We're going to focus on the underlying concepts and algorithm ideas in machine learning. So basically, we want to introduce all the important concepts we feel is necessary, right, in machine learning. I want everyone to understand that. And also, we'll introduce algorithm ideas. Right? We'll introduce a set of very classical, yet very popular, very successful machine learning algorithm to reflect those kind of ideas. Unfortunately, this course is not about using some specific machine learning tool like TensorFlow or PyTorch. Right? Later, we'll have some guest lectures introducing the usage of those tools, and we'll leave some examples. We share some examples for you to run, but we won't spend like whole course talking about those tools. And we won't focus on any single learning paradigm like deep learning. Right? If you're big fans of deep learning, we have a particular course is called deep learning, and we also have a deep learning certificate in our class on Thursday. One professor in our department will introduce this deep learning certificate and introduce a lot of like a very interesting, exciting projects along with that. So you guys can think about that. Okay? But for this course, because this is a introductory level machine learning course, we focus on basic concept and algorithm design. Any questions so far?
Will we do some programming?
Yes. You're gonna do heavy programs. Yeah.
Good.
Yeah. Any other question? There's no restriction on the programming language, but we highly recommend you to use either Python or MATLAB. You can use MATLAB. I mean, when I was a PhD student, I loved MATLAB. I don't like Python. But right now, Python is everywhere. So, I mean, I don't have any objections if you prefer Python. Or you can use R if you're more towards the statistic background. I know that like statistic people like R. Yes, we will provide data set. We'll give you the example data set. We don't want you to spend time like pre-processing those data sets. It will take quite a while. Yeah. Yeah, for project, yes, you have to do that because we want you to go through a whole procedure of developing machine learning algorithms to address a particular problem.
There's a lot of articles right now for the machine learning. How do you recommend that these articles do?
That's a very good question. Yeah. So when I was a PhD student, the top venue, like I just give one data point, like the one top venue is called NeuralNIPS. Maybe you guys have heard that. When I was a PhD student, I think some year there are about 3,000 submissions to that conference. Like people kind of like saying, okay, this is crazy. How can we sustain this giant conference? But guess what? After less than 10 years, every year you get more than 11,000 submissions every year. And even paper got accepted, every year you got like 1,000 or 2,000 acceptance for those papers. So yeah, that's a big problem, right? And even like a few days ago, I asked my students to investigate the published papers in the top venues in machine learning. I said, okay, don't look at the abstract, just look at the titles, and just give me a hint, like what kind of research topics are good and hot, and what kind of topics are not that popular. And they told me that they are not able to do that because there's so many titles, right? You imagine that you got like 2,000 paper titles to go through, right? You want to extract useful keywords. and then eventually use another machine learning model to summarize which keywords and which topics might be useful or popular. That's definitely a challenge, but I guess right now it's unrealistic to go through every paper. Like you have to leverage some like semi-automatic technique, I guess. Other questions?
We have a lot of programming. Do we have enough GPU to use?
No, there's no need to use GPU because this is a again this is not deep learning course. The data set is kind of like very small. We want you to implement a set of algorithm we're gonna discuss in the class to get a sense, right? To know them. You don't need to use GPUs. And for neural networks, we're gonna introduce like 1 million fancy neural network architectures. That's not our job. That's the job of another deep learning course. But we want everyone understand what is backpropagation, because that is the key underlying procedure of training a neural network, and everyone will be asked to implement your own backpropagation. Like you're not allowed to use PyTorch to do automatic differentiation. Okay, yeah, those are you guys are asking great question. Any other question? Okay. Huh? Not necessary. I mean, we're gonna tell you which particular type of libraries are forbidden, right? But we encourage you to use like matrix computation libraries like NumPy or default libraries in MATLAB, okay? Or optimization. I mean, in some scenario, like when we talk about support back machines, we don't want you to implement a convex optimization algorithm from scratch. You can call SciPy optimize to do that for sure, right? But when you implement the gradient descent, stochastic gradient descent, of course, you have to do it by yourself. We'll give some explicit request at that time. Other questions? For the project, it depends your choice of the projects, right? But we're not going to help you to process the data set. You have to process the data set yourself. Of course, you can use some publicly available and pre-processed data set. It's totally fine. What? NLP? No. Yeah, we're going to talk about NLP. Of course, if your project, you want to do some large language models, it's totally fine. Yeah. Other question? We'll talk about details later. Well, actually, we have 2 types of projects we're going to discuss later. Okay, so yeah, thanks for these questions. We're gonna touch the details in a minute, right? So that before that, here are our suggestions to take this class, right? So how can we effectively capture the course content and improve the skills and feel like, okay, I really learned something, right? Not being tortured by something, right? So I highly recommend everyone to take classes in person to learn the models and algorithm, right? And finish the homework assignments to deepen your understanding. You see that actually the workload for homework assignments is pretty heavy. Right? And we'll ask you to implement the learning models and algorithm by yourself and debug it by yourself and show your implementation is really working. And also, we got course project. I hope that doing course project to give you the experience that use machine learning to address problems. So here's the general workload. Right? We got 6 homework assignments, and most of them including both LaTeX and programming problems, in text problems. And I don't know if you are aware of, actually, we have a released homework 0 today. That's a basic knowledge test or review. I just want to ask you to refresh your mind, like some basic knowledge about calculus, about statistics, about gradient, linear algebra, right? Please start doing that early. Like if you feel like super difficult or you're sick of those type of problems, maybe you can think about whether it's worth your time to take this class. We got 6 homework assignments in total. We got 1 course project, right? And we want you to give midterm project report and the final project report. I want to see your code, the project code. Right? And we got 1 final exam. Right? We don't have a midterm exam. I don't like too many exams. Right? I think 1 final exam should be good enough for us to review what we have learned throughout the semester. Right? Open book. And we'll talk about the policy in a minute. Right? So here I just want to give some warning message. Right? So this course is one of the most is one of the most challenging course in the CS department. The workload is heavy, and there are some students complain that they can take approximately 20 hours per week. I would say this is just like no, I would say this is like a universal experience. It's just a singletons, right? But I honestly want to share these data points with you guys, like to let you fully aware there might be some challenges or time-consuming stuff in taking this class. Again, I want everyone to learn something they feel like valuable from this course rather than being tortured, right? And that's why I guess some of you have sent me the emails, ask for the permission code. I always ask, okay, what do you feel like linear algebra? What do you feel like calculus? Or what do you feel like programming? It's just to ensure that, okay, you won't feel hurt to take this class. Right? And again, if you feel like you're not well prepared for this class, you can just sign off and make some preparation, because we have this class every semester. Right? We got fall, we got spring, we got fall, spring, and of course the spring. In the spring semester, it was taught by another faculty member, but we share the slides. Okay? The content is highly overlapping. Okay? So don't worry about you're gonna miss this class. You're gonna take that next year. No, it's if you feel prepared, you can take it any semester. Okay? But we leave this message just to let you seriously consider whether you're gonna take this class. Okay? And seriously consider whether you're going to have enough time and you're willing to commit enough time and efforts to take this class. Okay, any question? Yeah, and personally, I would like to increase the credit to 4. I think 3 credits is a little bit smaller than what really this course content is, right? But it's up to the approval of the admin. It's not to me. So you feel like, okay, it's not fair to just give me 3 credits by taking this class. I spent so many time and nights, right? Yeah, but yeah, I agree with you. I agree with you, but it's not my decision to increase the course credits. Okay, so again, be cautious when you make the decision, right? We got 2 weeks and we got homework 0 to test your acceptability of this course, right? So we just want you to be cautious, right? So I think the next a bunch of time we spend, and please bear with me, I'll spend maybe this lecture and another lecture to talk about the specifics of this course, the overview of this course. We talk about every aspect and requirement of this course to give you a sense. We want to explicitly tell you what is our requirement, right? So that to let everyone to be aware, okay, everything about this class so that you can make a wise decision. Right? I don't want you to regret to register this course, right? I don't want you to to be angry about me. Okay, so I think there are two. There's an important resource in addition to Canvas, right? It's a course website. Actually, all the important information is released in the course website. So I'm gonna walk you through the course website. So let me show. I'm gonna share with my web browser. Yeah. Everybody see maybe the font is too small. Yeah. Is it better? Okay. Yeah, so we got a website, a course website. So it's very easy to find it on the web. Like if you don't mind, you can search my name in the Google, and the first entry will be my homepage, right? And under my homepage, this is me, and on my homepage, there's one section called teaching, right? So the top link points to our course website. So you just click this, and it will lead you to this course website. And this course website contains all the information as I just mentioned, right? So there's one main page, just talk about the schedule. It's from Tuesday to Thursday, and of Tuesday and Thursday from 9:10 to 10:30 in this big classroom. And this is where the final exam will be. And this already have been scheduled in the official website. If you are not sure about it, you can check the official page here. And regarding whether I'm gonna do online exam or in-person exam, I haven't decided. But in the past few years, because of the COVID, right, we always did this online. It feels like everybody sounds like everybody feels happy about that, because you don't need to like get up so early and drive here, right, and sit in this cold classroom and spend like 2 hours, right? So everybody just get up and sit in front of your computer, do this online exam, right? But we need some time to decide. Maybe we'll just make a vote, right? If everyone prefers to do online exam in the final, we can do it again. And here's me instructor. Here's my office. Here's my email. And we got 3 teacher assistants, Teruma, Novella, and Xiaoya. And these are all their contacts. And here I want to emphasize, right? We got office hours scheduled every weekday, like from Monday to Friday. So here our office hour schedule, right? I did office hour every Tuesday and Thursday. That is a lecture day, right? So the remaining 3 days, the office hours are done by our 3 TAs. Right? So Tiruma will do the office hour on Monday from 9 to 10:30, and Friday 9 to 10. And Novella will do the office hour on Wednesday and Friday, and Xiaoya will do the office hour on Friday solely. Right? So notice that, right? There's a interesting point in this office hour schedule. Right? We got very long office hour on Friday. Do you know why? Yes, exactly. Yeah. I know that because most homework assignments will be due on Friday, and according to our experience, 95% of time the office hour is just empty, and then on Friday there's a long queue, office hour. So we try to schedule as much time as possible on Friday. We got 3 TAs on Friday. You see that? Yeah, we actually all our 3 TAs have their office hour on Friday, right? Most time they will be in the room listed here. But if they have some other schedules, they cannot show up in the office room. They will schedule some online.
So you can see if we want like online also.
Yeah. Again, here's something I always trying to emphasize. Please leverage office hours. Right? So try to offer as much help as we can to help you, better do this class and do everything. But according to our experience, most time the office hours is just empty. Right? The TAs just stay there and doing their own stuff, or maybe watch YouTube. Right? So yeah, why not just stop by the office hour, ask questions, ask them to check your code and then verify stuff, right? So it's always like, okay, at the deadline, and so many students just run to the office hour, and the TA are busy, and students are complaining that, okay, why I cannot get enough help, right? So yeah. Question.
How many hours we spend on that project, that homework project, that moment?
No, I don't think that much. So that's a good question. So basically, we want you to be as effective as possible to take a class. I mean, I'm not trying to frighten you that, okay, this class is so hard, take so much time. It's not like that. So if you seriously take the class, right, and try to interact with the instructor effectively, you won't spend too much time after the class. But you do need to allocate time doing your homework.
The reason I'm asking how much time, how many hours, based on the office hour, probably like more efficiency. That's the reason.
Yeah, try to come to the office hour, not only on Friday. Yeah, try to come on Monday, Tuesday, Thursday, Wednesday, right? Try to on this right, and try to, which we always try to like have some kind of even split on those hours, but we found out it's practically infeasible, because it's always like Friday office hours will be more busy, right? But if you want to leverage more efficiently, I would highly suggest you to like start doing your homework early, so that you got chance to talk to the TAs earlier, right? That means you can talk to them on Friday, on Monday, right? I guess not. Yeah, because the when TA they are in the office hours, like students are coming by, right? They have to answer their questions. They cannot maintain a Zoom room at the same time, right? But if they are not able to come to the office, like due to some reason, they can open the Zoom office. Of course, you can ask question online. Another question? Okay, I guess we should stop here today, and we're gonna continue with the course policy and syllabus in the next lecture. So to ensure that everybody is fully clear about, okay, what this course about, what is our expectations. Okay, see you on Thursday.